Assalamualaikum warahmatullahi wabarakatuh and greetings. Today we will be presenting about our industrial visit for OSH and manufacturing technology subject which took place at Jimah East Power Plant, Port Dickson. We will be sharing knowledge and observation that we gained on manufacturing processes and technologies during the site visit. So our group consists of 5 members starting with Khairul Fikri, Ahmad Daniel Haikal, Muhammad Hakimi, Muhammad Adli and me myself Norman Irham Amar. So these are the summarization of the contents on what we will be presenting today. Jimah East Power Plant, a major coal-fired power generation facility located in Port Dickson, Negeri Sembilan. Construction began in 2015 and it has since become a vital contributor to Peninsula Malaysia's electricity supply. This plant has a total capacity of 2,000 megawatts with two units of 1,000 megawatts each. It uses ultra-supercritical coal burning technology, boasting an efficiency of 40%, which is higher than conventional coal plants. Jimah East Power Plant and now plays a significant role in increasing Peninsular Malaysia's total capacity to 25,981 megawatts. The plant is owned by TNB, which holds a 70% stake, with Mitsui and Co Limited and the Chugoku Electric Power Co Limited, each holding 15%. Unit 1 achieved its commercial operation date on August 22, 2019, and Unit 2 followed on December 27, 2019.
Moving on to the manufacturing process. Here are the step-by-step process of a coal-fired power plant involves converting coal into electricity. The first step is coal handling and preparation. Coal is transported to the power plant via train, trucks or conveyor belts. The coal is stored in the coal yard. The raw coal is crushed into smaller pieces. It is then pulverized into fine powder to improve combustion efficiency. The pulverized coal is fed into the boiler through a conveyor system or feeder. The next step is combustion in the boiler. The coal powder is burned inside a boiler furnace at high temperatures. The combustion releases heat energy, producing flue gases. Heat is transferred to the water tubes surrounding the boiler. The water turns into high pressure steam. The third step is heat generation and expansion. The heat from combustion boils the water, creating high pressure steam. Steam is passed through superheaters to increase temperature and pressure, making it more efficient for power generation. The fourth step is power generation. High pressure steam is directed onto the blades of a steam turbine. The turbine spins at high speed, converting thermal energy into mechanical energy. The rotating turbine shaft drives a generator. The generator converts mechanical energy into electrical energy. The fifth step is condensation and cooling. After passing through the turbine, the low energy steam is cooled and condensed back into water using condenser. Cooling towers or water sources removes excess heat. The cooled water is recycled to the boiler. Next step is electricity transmission. The generated electricity is stepped up to a higher voltage for transmission. The electricity is transmitted via high voltage power lines to substation. Voltage is stepped down at substation for distribution to homes, businesses, and industries. The last step is waste management. Electrostatic precipitators removes ash particles from the exhaust gases. Fly ash is captured from the exhaust gases and can be used in constructions. Bottom ash is collected from the boiler and disposed of in landfills or reused. That is all for the manufacturing process. Thank you.
Okay, so for the design concept of Jimah power plants, they reflect a balance between maximizing operational efficiency and maintaining reliability. Okay, first design concept that they use is supercritical technology for efficiency. Jimah Power employs supercritical and ultra-supercritical steam technology, a state-of-the-art system in a coal-fired power plant. So they use a high pressure and temperature. So the steam is generated at extremely high pressure and temperature, typically move about above 540 degrees Celsius and with 24 MPa, which improve the thermodynamic efficiency of the plant. Second is they use the lower coal consumption. So the higher efficiency of the process reduce the amount of the coal required per megawatt hour of electricity and produce. So minimizing resource consumption. Okay, the second concept is design concept is the modular and redundant system for reliability. Okay, to ensure continuous and reliability power generation, the plant integrate modular and redundant system such as backup units. So the backup units, the essential systems such as feed water pump and cooling system are designed with redundancy to avoid single point of failure. Then they also make automatic monitoring system. So advanced sensor and real-time monitoring sensor tool helps detect issue early, prevent the major failure. And then the last design is environmental safeguard and compliance. Okay, for the safeguard and compliance, they use a low nitrogen oxide burner. So the burner are specifically designed to minimize nitrogen oxide emission during combustion. Also, they use a flue gas desulfuration (FGD), where the FGD units capture sulfur dioxide emission from the flue gas. And the last one, they build electrostatic precipitator. The system remove fine particle, fly ash, from the flue gas before it released to the atmosphere. Okay, for the quality assurance, they maintain through rigorous inspections, performance testing, and compliance with local and international standards. They maintain schedules and predictive analytics further to ensure reliability and safety.
Okay, next, we go for the product produced at Jimah East Power Plant, Genco Tenaga Nasional Berhad. So firstly, the product that is being produced is electricity. This electricity are produced from three types of energy sources, which is coal, hydro, and gas. Okay, the sources that mostly used in the company is coal, and the coal is usually supplied from Indonesia because Indonesia have a lot of coal to supply. And comparing to these three types of sources, coal is the one that generate most electricity compared to hydro and gas. But based on NETA, which is National Energy Transition Map, the usage of coal will not be used anymore because it is to avoid air pollution. So the company will approaching to this problem by using more on hydro source and gas source. Okay, secondly, the product produced are flat ash. Flat ash is a material that is needed through creating concrete cement. This is because when generating electricity from coal, flat ash also could be created. So the selling for flat ash is not that big of a sales, but it's still making money than to throw it as a waste, because flat ash is a compulsory component in creating concrete cement. And then lastly, we go for product produced it is supplying electricity through transmission line or grid. The electricity will flow through transmission lines across Semenanjung. The transmission lines is connected across Malaysia, Thailand, and Singapore. This is because of the pressure on the transmission line will need to be in stable or steady state, which is required 50 Hz. In Malaysia, the frequency need to be 50 Hz, but in other country there are they are they have their own value of frequency. This is crucial, especially for factory user, because they needed high amount of electricity to run their machine.
Now, I will talk about problem faces by Jimah Power. During our site visit to Jimah Power Plant, we spoke with Tuan Ayub about some challenge they face. One major issue is the quality of coal received from Indonesia. The coal has a high moisture content, around 30 or 40%, which reduce its energy output and means they need to use more coal, increase cost. The quality of coal also change between shipment, making it hard to keep the plant running smoothly. Some coal has higher ash content, which can damage equipment, cause boiler issue, and require more maintenance. Additionally, coal can heat up on its own during storage, posing a safety risk. So, careful monitoring and proper storage are needed to prevent accidents. The second problem faces is healthy and safety risks. Handling coal also come with healthy and safety risks, making it important to follow safety rules. Worker must wear the right proper protective equipment (PPE) like mask, glove, and glove to avoid breathing in coal dust or getting skin irritation. Good ventilation is needed in coal handling area to keep dust level low. Regular equipment check and proper storage are crucial to prevent fire or explosion. By wearing the right PPE and following this safety measure, the risk can be managed efficiently. At Jimah Power Plant, continuous quality improvement is a key focus to solve the challenge they face and keep everything running smoothly. First, they regularly test coal shipment to make sure the quality is consistent. If the coal are issue like high moisture or ash content, they use blending method to balance it and improve the performance. To prevent risk, they improve how coal is stored. Using better facilities and advanced tools to monitoring coal and stop it from heating up by itself. They also upgrade their technology like using advanced boiler and maintenance system, while which help handling coal with fewer problems and keep equipment in good shape. Safety is another important area. Workers are trained to follow safety rules and use the right protective gear like mask and glove to stay safe from coal dust and also other risks. Regular check and inspection also help prevent accidents. With this step, the plan is working in improve efficiently, reduce costs, and provide a safer environment for everyone.
Now I will discuss the Jimah East Power Plant and opportunities for improvement in its operations. The plant uses ultra supercritical coal burning technology, which improves efficiency to 40% compared to 36% in conventional plants. However, challenges like environmental concerns and operational reliability present opportunities for advancements. To reduce its environmental impact, the plant could incorporate carbon capture and technology (CCS) and explore blending biomass with coal, which will decrease fossil fuel dependency and promote greener operations. Maintenance and ash disposal are also key challenges. This could be addressed with predictive maintenance powered by AI and IoT, ensuring reliable operations. Adopting circular economy practices like converting ash into construction materials can help reducing waste. Lastly, the plant can explore cogeneration opportunities using surplus heat for district heating or industrial applications, thus allowing in boosting resource efficiency.